Okay, modeling with KNOSSOS EU. This is part 1 of 4 webinars. So this is the first webinar of a session and a series of 4 webinars. The agenda for today is I'll go into the latest news from SoftNoise. Then I will go into the KNOSSOS method. I will go into the implementation of KNOSSOS in Predictor. I'll show you the project flow, and then I will be open for questions. First, the latest news. Last month, in April, we released the new version of Predictor, Predictor Lima version 2021.1. Also, we have signed a cooperation agreement with DMDB, the company of Douglas Menville, the new company of Douglas Menville, well known to the noise world. And Douglas will be helping me with the promotion and the support of the Predictor Lima software. So we will have a strong cooperation here. Also, what's new is that SoftNoise has taken over the Predictor Lima support and sales from EMS B&K. So that means that all Predictor Lima users worldwide can now have direct support from SoftNoise and also can purchase their upgrades directly from SoftNoise. So there's no middleman anymore. And that's of course in the benefit for everybody. It has more interesting prices, direct support, and of course SoftNoise was always the developer of the Predictor Lima portal and the Predictor Lima software. These are the 4 webinars. Today, part 1. Next week, part 2. Then I'll go into the import from GIS. Then the week after, part 3 for the tiling and calculation. And then the week after, the population exposure, part 4. KNOSSOS EU method. It is defined in the Commission Directive 19th of May 2015. It was published on the 1st of July. And it describes one propagation method for industry, road traffic and rail traffic, including source models, and a separate method for aircraft noise. Ground operations for aircraft noise can be calculated with the industrial method. It calculates the long-term equivalent noise level, so you have to be aware it's not the maximum noise level or peak noise level, no, it's the long-term average equivalent noise level for industry, rail and road in octaves from 63 to 8000 Hz. It calculates the air absorption according to the ISO 9613.1, default settings 15 degrees Celsius and 70% humidity, and this is now of course the first mandatory method to be used for the European noise map in 2022, next year. So that will mean that this year the member states will start setting up their projects, and the 1st of July next year these projects must be finished and the data must be handed over to the European Union. At the end of last year there were amendments and quality assurance methods released. In November 2020 the ISO organization published the ISO 17534-4. The recommendations for a quality assured implementation of KNOSSOS in software. And also at the end of last year, the EU Commission published an amendment on the KNOSSOS EU method. And these amendments were mainly based on the RIVM report of 2019. And in April last month, we, SoftNoise, released Predictor Lima version 2021.1, and this version is quality assured according to this final quality assurance method, and it includes the amendments of this new document at the end of last year. So we're fully up to date. Okay, the KNOSSOS EU method. As I said, it calculates the noise propagation for road, railway and industrial sources. And what's important to realize is that it uses 2 meteorological conditions. One which we call favorable, and that's the downward reflection propagation conditions, and homogeneous. This means that it's better than the ISO 9613 because the ISO 9613 could only calculate in a in a downwind situation. And with KNOSSOS, you can not only calculate in a favorable, let's say a downwind situation, but also in a homogeneous situation. So this is already much better than the ISO. Of course, the KNOSSOS method could also calculate in an upwind situation. So that's even better than the KNOSSOS method, but as we all know, the KNOSSOS method did not make it in Europe. We have to use the KNOSSOS EU method. The road source model is defined 5 standard categories: light, medium heavy, heavy, two-wheelers, and an open category. The source height of all 5 categories is 5 centimeters above the ground. So for light vehicles, heavy vehicles, two-wheelers, the source height is 5 centimeter, one source height. It has a complex source model depending on rolling noise, propulsion noise, the tires could be studded tires, acceleration, deceleration close to crossings, crossing types, road surfaces, and slope gradient. The rail source model is even more complex. It's depending on rolling noise, wheel roughness, impact noise, switches, junctions, squeal, traction noise, aerodynamic noise, directivity, bridges, steel bridges, for instance. The source model is 1/3 octave for the rail source model. However, for the propagation and the calculation, full octaves are used. So this means that Predictor first calculates the sound power levels per 1/3 octave, but then converts it to full octaves. There are 2 source heights used for rail sources, 0.5 meter and 4 meters above the rail track. And the rolling noise is assigned to the 0.5 meter height source. Traction noise is divided over the 2 source heights. Aerodynamic noise is divided over the 2 source heights. And the impact, squeal, and bridge noise is assigned to the source at 0.5 meter height. Then the KNOSSOS method in Predictor. So when you create a KNOSSOS model in Predictor, you can now enter all source types. This means you can enter roads, railways, and industrial type of sources, like point source, line source, etc., including the wind turbine. By using groups, the results per source type can be evaluated for noise exposure. So you can create groups in a Predictor model, and you can put the roads in the road traffic group, the railways in the rail traffic group, and all the industrial type of sources in the industrial noise group, because the EU member state have to report the EU noise levels per type of source. Predictor uses the Lima KNOSSOS calculation core, which of course has the advanced Lima dynamic source segmentation technique. Then, when you look at the KNOSSOS calculation settings in Predictor, you can select a meteorological location over here. And when you click on the yellow folder icon, you come in this form on the right. You see that you can select a location. There's a default location, but there are also other locations, and you can create your own location. And here you see that per location and per direction and per period, you can define the percentage favorable. So in this case, if you have selected default, then, oops, sorry, I have to close down. Then all directions is 50% favorable in the day period. It means also 50% homogeneous. 75% favorable in the evening, so 25% homogeneous, and 100% favorable in the night period. But you can select and change per direction. So you have to know your local meteorological conditions, and knowing also in which wind direction it is blowing. Okay, coming back on the meteorological conditions. So you define it in percentage favorable, and the remaining percentage is automatically the homogeneous situation. You define it per day, evening and night period. You define it per wind direction in 20-degree angle, where the positive y-axis is assumed to be north, and the positive x direction is assumed to be east. That means that a wind direction of 0 degree is from the north, and a wind direction from 90 degree is considered coming from the east. The meteorological conditions in Predictor, the regions are taken from the NMPB 96. And you can add your own meteorological conditions, of course, your local meteorological conditions for your agglomeration. Then the source databases in Predictor. There's an industrial noise source database that contains the Imagine EU sound powers. So we call that the Imagine EU sound power database because this database has been created within the Imagine EU working group. There's a road source database with the default road vehicles and the road services, default road services catalogs. And these are XML files located in the Predictor program folder. I will show you later on. These two catalogs contain the characteristics and types of vehicles, crossings, and road surfaces. And it is based on Appendix F from the KNOSSOS standard. Then there's a rail database with the default rail vehicles and rail tracks catalogs. And these are also XML files located in the Predictor program folder. These catalogs contain characteristics and types of rail vehicles and tracks, and they come from the Appendix G from the standard. These XML formats of these catalogs have been defined by DGMR within the KNOSSOS EU working group. And these are open formats, and because it's an open format, they allow adding your national road and rail vehicles. You can use, of course, the default road and rail vehicles, but you can also add and define your own local road and rail vehicles. Okay, I just switched to Predictor. First, I want to show you the calculation settings. I explained that in the calculation settings, by selecting this yellow folder, you can select the specific meteorological condition, location, but you can also add your own location. Like I explained, the default road and rail catalogs are located in the Predictor program folder. I'll show you these catalogs. Let me just open the File Explorer, and then I'll open this one. I go to the Predictor program folder, and here you see these 4 default catalogs, XML files. And if I open the road parameters, for instance, double click on the XML file. Here you see it's a text format, but of course a specific text format. And here you see all the data that is in this catalog for all the standard categories, the road vehicles. Similar for the surfaces. If you open the road surfaces, here you see all the road surfaces, the default road surfaces. All kind of layers, all kind of surfaces. What happens when you create a Lima KNOSSOS model in Predictor, then these default catalogs are imported in the model, in your Predictor model. And you can view these catalogs by using the road and rail catalog buttons on the calculation setting form. You can of course replace these catalogs by importing. You can use the import options for the specific catalog. So you can create your own catalog, your own national catalog, and I'll show you how you can import it in Predictor. You go to the calculation settings, you go to road catalog, and then there's an import button. So there you import your own national, from Czech Republic or from any other EU member state, your own national road parameters. And you can also export the one you used in this model. That goes for the road, and it also goes for the services. So that goes for the vehicles and for the services. Similar for the rail catalog. If you click on the rail catalog, you can import another rail vehicle catalog, or import another rail track catalog. So that makes it possible to enter and use your own local vehicles. Okay, that's about rail and road vehicles. Well, these are the forms I've just shown you. The road catalogs, the vehicles, the road catalog of the services, the rail catalog with the vehicles, and the rail catalog with the tracks. Then in Predictor, if you enter a point source in Predictor, you will see here a sound power level entry fields, but if you click on the yellow folder icon, then it opens the Imagine EU database. That's included. So you can select one of these source types, and then it automatically fills in the entry fields in your point source form. For the road entry form, here you see the 5 categories, category 1, 2, 3, 4A, 4B, and 5. And there, per category, you enter the traffic flow and the traffic speed for that specific category. And then in combination with the selected road surface, here you select the road surface from this road surface catalog, of course. Depending on these settings, Predictor calculates the sound power level for the day, evening, and night period. That's how it works in Predictor. Similar for the railway. Here in the railway, you have to enter the number of, first you have to select the train type, and there's a list of 24 train types in Predictor. And you also see here 22 is RMR category 8. And RMR category 8 is, of course, taken from the interim method, the interim RMR method. I'll just go to the next sheet. Here you see the original RMR train categories that are most likely used in the EU member state for the interim rail traffic noise method. And the RMR supported 9 categories. Then if I go back to the entry form again, so here you see that train type 23, that's RMR category 9. And 22 is RMR category 8. So here you select per train type how many vehicles there are, because here is the traffic flow in number of vehicles. Then go to the track definition. You select what type of track, the structure, the rail roughness, impact noise, if it's a bridge or not, and the curve radius. And then based on these settings, Predictor calculates the sound power level again per source height, because rail traffic noise has 2 source height, one on 0.5 meter and one on 4 meters. So you see here the sound power level per period, but also per source height. Okay, so that's the railway. And these are the RMR train categories that are also included in the XML. Then my last sheet, this gives you an overview of the project flow for a KNOSSOS EU population exposure project or an EU noise mapping project. Of course, you start by finding all available GIS data. So you have to find your buildings, your roads, your ground cover, address points, and your height lines. And this, of course, takes a big part of your project. Then in Predictor, you've got 7 steps. First, you import your GIS data. Then you create your receivers at facades. You tile your main model. You calculate it, either by local calculations or you use the Predictor Lima Cloud calculation service. Then you import the tiles again back into the main model. Then you've got your complete result set for your complete agglomeration in one Predictor model. Then you can use the EU population exposure option, and then you're ready. Then you can export the EU population exposure to Excel or GIS. And so the next webinars, part 2, I will discuss step 1 and 2 of this project flow. Part 3, the webinar part 3, I will discuss steps 3, 4, and 5. And that's tiling and the calculation and the import of the calculated tiles. And then part 4, I'll go into steps 6 and 7 on the 27th of May.